Hi, in this video I'm going to talk about complex numbers. What are the complex numbers and what are the elements of complex numbers? So complex numbers came about as a result of trying to figure out how to deal with an equation like this one. X squared plus 1 equals to 0. If we transform this equation we get x squared equals to minus 1. And according to what we have known so far, there is no way of finding a solution to this equation because we cannot take a square root of negative number. Those square roots don't exist. But Italian mathematicians in 15th and 16th century came up with a way of dealing with these kind of equations. And the way they did it was more or less as follows. Let's say, imagine that there exists a number. There exists an imaginary number that equals to square root of minus 1. Square root of minus 1. That number exists. So let's say that this imaginary number, we're going to be calling this number I. So wherever we see a square root of minus 1, we can replace that symbol with letter I. So then, if I wanted to solve an equation like the one above, I would say that x squared, which equals to minus 1, and taking square root of both sides, I can get that x equals to plus or minus square root of minus 1, which is equal to plus or minus I. And that's the solution to this particular equation. In another example, we can take a look at x squared equals to minus 4. So if I wanted to find a solution to this equation, I would have to write something like this. X equals to square root plus or minus square root of minus 4. And minus 4 can be rewritten as square root of minus 1 times 4, which then can be separated into two separate square roots. Square root of minus 1 times square root of 4. So square root of 4 is equal to simply 2. And square root of minus 1 is equal to I. So solution to an equation x squared equals to minus 4 is plus or minus 2i. So that's why complex numbers came about. But I guess the name suggests that there is more elements to complex number than just that. So by custom, we're going to say that our complex numbers are going to be denoted by letter z. So letter z is indicating that we're dealing with a complex number, and we're going to say that a complex number can be written as something as follows. We have a complex number 2 plus 4i. This is an example of a complex number, and you can see that it consists of two parts. Those two parts have a specific name. This part here, the one that is a number, this is called the real part, and we normally denote this Re of z. So if you see Re of z, it asks you to tell me what is the real part of complex number z. On the other hand, this is imaginary part of a number z, and we call this part Im. So this is the imaginary part of the number z. And if you see Im of z, this asks you to tell me what is the imaginary part of number z. And in particular, we are interested in this number here, the number that is the coefficient of the imaginary number I. So in particular, we're interested in this. So complex numbers, another example of a complex number would be z equal to 1 plus I, where real part equals to 1 and imaginary equals to 1. Another example of a complex number z equals to 3 minus 7i. Real part of z equals to 3. Imaginary part of z equals to minus 7. And that's it. So for the moment, the key thing, there are three things that I would want you to remember. The first one is that I equals to square root of minus 1, and as a conclusion, I suppose as a consequence of this, I squared equals to minus 1. So I, the imaginary number I, is the only number that when squared gives us a negative number result. So this is the first thing I want you to remember. The second thing I want you to remember is that complex numbers are normally denoted with letter Z and consist of two parts. And I'm going to say that we have complex numbers at 3 plus 2i. And the part without the imaginary number, so the part without I, is called the real part. And the part of a complex number that contains the imaginary number, that's called the imaginary part. So these are the things that we should remember from this video. In the next video in this series, we're going to talk about how to add and subtract complex numbers of this form.